Okay, so we are still in the middle of this hat problem, as they call it, and you must listen to section 1 because it just stopped in the middle of a sentence or a paragraph. So you must listen to the first one to understand what we're talking here. Now, Mr. D walks in, and as I said, he is right now standing next to his chair. You can't see the guy, you can just see he put down his chair, and he's in a very big dilemma because he does not want to sit down on his chair, because then he would be matching to his own chair. He doesn't like that. He wants every single guy in this room should not match his chair, just like Mr. C does not sit on his chair, Mr. A does not sit on his own chair, Mr. B does not sit on his own chair. The same, Mr. D, does not want to sit on his own chair that he put down. So what does he do to solve this issue? He can do two things. Either he kicks somebody off his chair and he exchanges with him. For example, he goes to Mr. A. Maybe he doesn't have to kick him, he can ask him nicely, Mr. A, how about you take my chair? Obviously you're not gonna match because you're not Mr. D, you're Mr. A, right? He walks over to Mr. A. He says, Mr. A, please, you sit on my chair that I just brought in the room and let me sit on the chair that you are sitting right now. So the issue will be solved. Mr. A won't have his chair, he will have Mr. D's chair. Mr. D won't have his chair, obviously, because he just gave it away for Mr. A. So everything will be perfect. So Mr. D can do this either to Mr. C, to Mr. A, or to Mr. B. I'll write down all the possibilities how Mr. D can tackle this issue. Okay, put this close to the screen, you can see the whole story here. Okay. Okay. As you can see, Mr. D is trying to solve his issue. What does he do? First solution is he goes over to Mr. C. That's the second line of this paper. He tells Mr. C, please, do me a favor, let me sit where you are right now, and you go on my seat that I just brought into the room, and we'll both be very happy. I'll be happy because I'm not going to sit on my chair. You'll be happy because you will sit on chair labeled D. Obviously, it's a new chair I just bought in, it's not your chair. We both don't want to sit in our chairs. The second solution is, that's the third line of this paper, where Mr. D starts bothering Mr. A. He talks to Mr. A. He tells Mr. A, please stand up. You have a beautiful chair waiting for you. Let me sit on your chair where you are seated. And Mr. C and B, he does not touch them. He just lets them. They're older people. He doesn't want to bother them. He just bothers Mr. A. At last, there's the third choice. He goes over to Mr. B. C and A, he doesn't bother them. He just lets them. They're happy. He doesn't try. He doesn't want to get them nervous. He just goes over to Mr. B. He asks him, please get up. You go on my chair that I just brought in. I'll sit on your chair. So as you see in this paper, these are 3 solutions how Mr. D can get somebody off his chair, tell that guy, you sit on my chair, I'll sit on your chair, and we'll all, both be happy. The small letters means that he did not do to them anything. The bigger letters means that that was a change that was just made. So you understand very well what this paper is talking about. Okay. However, this is just one way that Mr. D can handle this terrible dilemma that he just walked in the room and everybody has a different label and it's different seat than himself besides him. So he's trying to get somebody to stand up and exchange. There's another method how Mr. D can solve this problem. What is that? That is when he walked into the room, there was exactly one person that did match his chair. Exactly one. The other 2 guys were messed up. There was 1 out of the 3 people that actually matched his chair. He walks over to that guy. He says, by the way, we're both here in deep trouble. You're in trouble because you're matching your chair. I'm in trouble because I just walked in with a chair that matches my t-shirt. Let's both team up and solve our shared problem. You go on my chair, I go on your chair. I'll draw this picture to understand what case is it that one of them is seated properly. The first case will be A is seated properly and C and B are messed up. The second case is B is in its proper position, and just don't worry, everything will be very clear soon. I'll make soon a summation and everything will be crystal clear. Just bear with me another few minutes. The first case is A is seated properly, C and B are messed up. The second case is B is in its proper position and A and C are messed up. The third case is C is in its proper position and A and B are messed up. These 3 cases are the cases where you can see the first line shows A is in its proper position and C and B are messed up position. The second case, B is in the center, he's in his good position. A and C are messed up. The third case, C is in its proper position and A and B are messed up. So here comes Mr. D, and he has a great proposition. He speaks to the guy that, let's say in the first case where A is in his proper position, Mr. D walks in, he says, hey, let me take your chair and you go in my position. That will solve all the problems in one shot. I'll write it down. Look, in the first case, A is in its proper position, so D tells him, please, move away from your chair, let me sit on your chair, you take my chair. I guess we'll both be helped. I'll be on your chair, I don't belong there, obviously. I belong the last one. And you'll sit on my chair, you don't belong there either. The second case, you see B is in its proper position. So D walks over to this guy that's in his proper position and he says, hey, you're in trouble. You're not supposed to sit there because that's your proper position. You're supposed to be messed up. So let me sit on your chair. I guess you would be helped because you are not going to be anymore in your proper position. And I will be helped because I'm definitely not in my proper position, because I just walked into the room and I bought a new chair. My chair is totally in the end of the room. So I'll sit on your chair, you, Mr. B, go on the last chair. The third case, Mr. D walks in, he sees Mr. C sitting on his proper position. Mr. C, you know you're in trouble. How about making a good deal? You get off, you stand up, go to the last chair, sit on the chair that I just bought in, and I will sit down on your chair. We'll both be helped. What is the moral of this whole story? Let's get the moral very clear, and we'll sum it up, hopefully in this video. We won't need another one. To sum it up, to get the picture clear, first of all, we make a list of all the ways that A, B, and C are all not in their good position. They're all messed up. That is this list here. The list that has only two ways that CAB or BCA. These two ways are the ways that everybody is messed up. So when D walks in this case, in these scenarios, then D needs to when D walks in these two cases, what D needs to do is he needs to go over to anyone and exchange chairs. Doesn't matter if he goes to C or to A or to B, and then everybody's will be in an improper position. D will obviously be in an improper position because he's not sitting on a chair that he bought in. The other guy will be in improper position because he's sitting on chair D. So let's make now a big summation. Let's first take these two cases, and then we'll go back to the cases we spoke a minute ago. These two cases, Mr. D, let's say in the case of CAB, Mr. D can exchange with Mr. C, with Mr. A, or with Mr. B. So there's three scenarios that will give us everybody in an improper position. However, Mr. D can walk in when the scenario is BCA, that's the second, that's this bottom, and the same thing can occur then. Mr. D changes with Mr. B, Mr. D changes with Mr. C, Mr. D changes with Mr. A. So we have all in all already 6 cases. I'll write them down on the paper and you be very clear you understand. 6 cases that we have everybody in improper position. These 6 cases are based upon 2 cases of 3 people sitting on everybody in an improper position. As you see, it's based on CAB and BCA. Upon this is based another 3 cases for each. I'll write it down, at least you see all the 6 cases. Okay. Let me explain this paper. Make sure everything gets into the video here. We start off with 2 major 2 roots, as I call them. It's CAB is one root and BCA is a different root. These roots are the cases where we have 3 people in the room that are all messed up. Mr. D walks in and he wants also to continue the messed up position. So, with the case of CAB, there is 3 that grow out of this root. Either D pushes C away, that's the first row. Either D pushes Mr. A away, or the last one, Mr. D, pushes Mr. B away. This is 3 that stem from this root. You get another 3 that stem from the root of BCA. Initially they are seated BCA. Again, the same story. Mr. D walks in. The first row he is exchanging with Mr. B. The second exchanging with Mr. C. The third one he is exchanging with Mr. A. That's the third case. Mr. D is asking Mr. A to stand up and exchange. Realize, in each of these rows, 2 people are not touched. It's only one out of the 3 that's asked to stand up and exchange. Okay, now we see our 6 cases that stem from these 2 cases. However, we have another few cases that are based upon the story where one of them is seated in his right place. And as I said before, for that we have a different sheet of paper. For that we have this paper that shows us that the first row A is properly seated, the second row B is properly, the third one C is properly. In the first case, where A is properly seated, D asks him, hey, let's make an exchange. The second case, where B is properly seated, Mr. D asks Mr. B to make an exchange. In the third case, Mr. D asks Mr. C to make an exchange. So all in all, we got here 3 plus 6, 9 cases. 9 cases. But let us see something. How did we... So we built up basically 9 cases from... We said there's only 2 ways actually to have 3 people totally disoriented. Now to have 4 people disoriented, we have 9 ways. 9 out of a total of 24, because there's 4 factorials 24. So let us, once we get this algorithm or the mathematics behind what we just did now, a whole process. Once we understand what we are doing, we can just extend this and extrapolate this on higher numbers. So let's understand what we're doing. Basically, we're doing very simple stuff here. We're first dividing the situations into 2 distinct sets. One is the case where the people are right now, the 3 people are disoriented. Everybody, in other words, and that we know already by default because we wrote it down or we figured it out. So we know how many cases it's possible to have 3 people disoriented. That is 2 cases. Each of these cases, since we're dealing here with 3 people, so it is 3 times 2, because in each case there is Mr. D that asks one of these 3 people, hey, let's exchange. That's how we built this paper. This is based upon this theory here. That they're all disoriented. There's 2 cases, and in each case there is 3 that stem from it, because the 3 is dependent upon how he asks each individual to exchange. That is 3 times 2, 6. But we're not done yet. We have to know, how about the cases where there is one guy that does have a right seat. However, Mr. D walks in, he is going to make sure to disturb that and take away that problem by telling him, hello, I have a mountain, you have a ditch, let me put my mountain into your ditch. Let me sit on your seat, you go on my seat. That's a beautiful solution. We'll both be helped. So we have to figure out now, how many cases is there that we have exactly 1 person on the right seat and 2 people not on the right seat, and that is 3 cases. This is this situation here. 1 person in the right seat, 2 people not in the right seat. Each of these cases has exactly 1 way of solving it. That is, asking the person that is on the right seat, let's swap. So we have here 6 plus 3 is 9. Now, just to make sure we understand what's happening here, let's just do it 1 more step to see we really know what's flying here. The question will be asked naturally, how about 5 people in the room? What will be, how many different ways can they all be, or each one and everyone disoriented? So we know already for 4 the answer is 9. We just figured it out, right? There's 9 distinct cases. I'll just enumerate them. DCBA, CDAB, BADC. This is on this piece of paper here. And then here we have DABC, CDBA, CADB, DCAB, BDAC, BCDA. Okay. Beautiful. Now imagine, I don't think I'll do now the list of papers. Now I want you to use imagination, not actually enumerate them, just use imagination. Now we have already these 9 different cases that each one is disoriented. Now comes in Mr. E, A, B, C, D, E. Mr. E walks in with a chair labeled E on a t-shirt that says E. So let's just use the same logic as before. If it's one of these 9 cases, Mr. D, in each and every case, can walk over to one of the guys and swap. So we have 9 times 4. That is 36. Why? 9 times 4. In each case, make a list of cases, right? Let's say BADC. Mr. E walks in. He can ask Mr. B to swap. He can ask Mr. A to swap. Mr. D or C. I'm just, for example, using the last thing here. That is BADC. This is the last one of the 9 cases. You can ask Mr. B, Mr. A, Mr. D, or Mr. C. Mr. E can swap with anybody of these guys, and it will be legitimate. Will be a legitimate case. That is why we can do 9 times 4. But we're not done yet. So let's put away the number 36. So we have 36 ways of making this process okay. However, we're not done yet. How about if Mr. E walks in and there is one of these people that does sit on his right seat? That's different cases. There's one person. For example, A is on his right seat, B is on his right seat, C is on his right seat, or D, whichever guy should be. He can tell that guy, please stand up, let me sit, and that's what. So this is like the second list, I call it, the second list. The list that he walks in when one of the guys are on his right seat. So let's first focus in a case where A is on his right seat. How many ways can we have A on his right seat and B, C, and D on the wrong seat? Hello, we just did that. Because we know that to have 3 people on the wrong seat, that's B, C, and D, there's 9 ways. So having A on his right seat, B, C, D disoriented, there's 9 ways. Now E walks in, he just goes straight to A. He said, hey, hello, you know you're sitting on the right seat, you're not in good shape, I'm not in good shape either, let's change. That's a case. How many ways can we have B on the right seat and A, C, D not on the right seat, same story. Let's just forget about the one that's in the right seat. He doesn't exist. We're just focusing on the other three that are each one on the wrong seat. We know that's 9 because we know that from before already that to have 3 people disoriented is 9. So the same logic carries by A, B, C, and D. So we have 4 times 9. So again, what we end up doing here, we want to find 5 people disoriented. So we say we can divide this scenario in 2 different stories. Either when 5 walks in, all the 4 people are already mixed up. And that we know from calculations that how many ways can all 4 people be mixed up? We know the answer is 6 plus 3 is 9. There's 9 ways. Each of these 9 ways, he can walk over to any guy and ask him to exchange his seat. He can walk over to A, B, C, or D. Since they're anyway mixed up, he's going to take over their seat, they're going to take his seat, it will still be mixed up. So that is 9 times 4 is 36. However, the same story can happen. He should walk in when there are 3 people, there are 3 people mixed up, 1 is on his seat. For example, A sits on his seat and B, C, and D are mixed up. How many cases can A sit on a seat and B, C, D be mixed up? So that's the question of having 3 people mixed up. That's only 2 ways. I think I said wrong before. Again, we have A on a seat and B, C, and D mixed up. So if we have A on a seat, let's not even talk about him. We're just focusing now on the other 3 guys, B, C, and D. And these 3 guys, none of them should be on their seat, is only 2 ways. Because it's essentially, it's like we're dealing with 3 people only, because A is out of the picture. Let's just imagine that ABC starts with a B. So we have B, C, and D, and we need to put them in the wrong order. There's only 2 ways. Everything should be this order. So we have 2 ways for that. Next, B is on his right seat, and A, C, and D are mixed up. Another 2 ways, and so on. So each of these ways, Mr. D always makes sure to exchange with the guy that's seated correctly. So let's cap it up. There's 2 ways that A can be on his right seat and B, C, D mixed up. 2 ways where B can be on his right seat and A, C, D mixed up. 2 ways where C is on his right seat and A, B, D mixed up. And 2 ways where D is on his right seat and A, B, C mixed up. So we have 2 times 4. That's 8. In each case, obviously, he exchanged the seat with the one who's on his right seat. So that is 2 times 4. That is 8. So we have 8 plus 36. That's the final answer. That is 6 plus 8 is 14. 44. There's 44 ways that we have 5 people messed up. 36 that follow from the case where all 4 are mixed up, and 8 that follow from the case where only 3 out of the 4 are mixed up and 1 is on his right seat. That is, we do that 4 times. So we have 44 in total. Out of 5 factorial is 120. So it's 44 out of 120. That is 22 out of 60, or 11 out of 30. That is the percent of, it's a little bit more than a third of having, as we see that we, by 3 people, by 4 people, it is 9 over 4 factorial. That is 4 times 3 is 12. 9 over 24. 11 over 30. By 3 people, it is 2 over 6. That's a third. So if you realize it gets smaller, and it is a certain limit to where it gets to 1 over e, but that's not the discussion here right now. We got the gist of it, and we got the method how to climb the ladder higher and higher. And I hope you enjoyed this. It was quite long, but I didn't expect it to be so long, so I'm sorry for that.